So, hi guys, this is lesson 1. This is unit 7, lesson 1, systems of equations and graphing solutions. So the first thing we're going to do is do definitions, a little bit of word vocabulary. So a system is a set of more than one equation which can be presented graphically, or algebraically. Now, if I spell that wrong, that's okay because I'm a math teacher, not an English teacher. Although usually my spelling is on point. Now, algebraic systems, these systems show inclusion with curly brackets and list the equations in vertical fashion. So usually we just list the equations. So this is equation 1, y equals x minus 1. And this is equation 2, y equals negative x plus 3. So what we're going to do is we're going to go to our graphing calculator real quick and put these equations in. We're going to go put these equations into the graphing calculator. So I'm just going to drag this over here. And I'm going to look at this system. So I go to y equals, put in my first equation. I have clear x minus 1. And what we're looking for is to see if these two equations intersect. And I press trace. And if I look, these two equations do intersect at this point. So we could try to go to that intersection. And get close to it. I don't see that I am. So I'm going to go to the table and see if I can look at this intersection. So second graph. So I press second graph. I'm pressing second graph. And I'm going to the table, looking for y values that are the same. So I'm doing that, right? Looking for my y values that are the same. And I might have to move up a little bit. I might have to move down a little bit. So looking for the x value where y values are the same. And I clearly see it now. It's right here. It's 2, 1. So here, my intersection is 2, 1. So a couple different things we could do to find the solution to those systems. Okay? But anyways, let's get back to what we should be doing here. So what we want to do with these equations is definitely number them, 1 and 2. So I'm just going to go through, number these equations, number 1 and number 2. Number 1 and number 2. Each time, all right, the ideal situation would be like when we have a situation where we have y by itself or we have x by itself. This one, we would have to solve for y or even x, okay? But we'll get to that later on. So graphical systems are systems that are depicted as a set of 2 or more lines or curves, or a set of points, all right? So we're going to figure out the solution here is the intersection. It's a point. It's a point. Sometimes it's more than one point. But here in particular, it's a point. And it's located at what looks like -2. My x value here is -2, comma, my y value is at 3. Now, solutions of systems are the intersections of 2 or more equations. They are the intersections of 2 or more equations. Solutions may be found algebraically by solving for x for x and y, or by identifying the points on a graph. So how do we check whether a point is a solution to a graph or an intersection? So an ordered pair is a solution if it is the point where two lines intersect, or if it proves the equations true when substituting it in. So what we're going to do is check to see if this ordered pair is a solution to the system. So it says, is the ordered pair, is this x and y value a solution of this system? This is equation 1 and equation 2. Does it make each equation true? Does the point make each equation true? So we're going to check. We're going to check y equals x minus 1. We're going to check y equals negative x plus 3. And remember, we use parentheses when we're substituting things in. So this equals, so does 1 equal 2 minus 1? Is this statement true? So 1 does equal 1, so this is true. So this first one checks out. The ordered pair is a solution for the first one. What about the second equation? Well, does 1 equal negative parentheses 2 plus 3? 1 does equal 1 here. So this is true. So it checks out. So our answer is 1, 2 is a solution to the system. And there's our proof. There is our proof. Looking at the next part is the ordered pair 2, 1. This should be 2, 1 up here. My bad. Is a solution to equation 1 here and equation 2 here. So writing it out, y equals 2x plus 1, and y equals negative x plus 4. We substitute in 1 equals 2, parentheses 2 plus 1. Well, does 1 equal 4 plus 1? 1 does not equal 5. So for the first one, not true. Check the second one just in case. Does 1 equal negative 2 plus 4? 1 does not equal 2, so this is not true as well. So we were right. 2, 1 is not a solution. The ordered pair 2, 1 is not a solution. Moving on to page 2, graphing systems and the intersection. So graphing solutions. So find the solution of a system of equations graphically by identifying the intersection, which is an ordered pair. So graph the two lines and circle the point of the intersection. So it says graph the systems and identify the points of the intersection. If there is no point of intersection, write no solution. Parallel lines, if the lines overlap, write all real numbers, coinciding lines. So first we need to make sure couple of things we need to make sure of. One, y is by itself. Okay. Two, identify M and B. Three, graph the lines. 4, circle the intersection. 5, write solution. Okay? So here, M equals 1 or 1 over 1. B equals -4. I'm going to go ahead and graph this first equation. Equation number 1. I'm going to label it y1. y1. So I graph -4, my y-intercept. I go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. Create my line and label my line. This is y1. Now for y2, identify the slope in front. Put a 1 in front always. That's equals -1 over 1. And b equals +4. So I go down 1, right 1. So I start here at +4, down 1, right 1, down 1, right 1, down 1, right 1. And I keep going and I see where these graphs overlap. I see where the graphs overlap. So I'm going to darken the circle and point out this point. It's right 4, 0. All right. So my solution is 4, 0. There is one solution here, one solution or one intersection. These are not parallel lines, and I'm going to label my equation. Now for the next one, I'm going to label my equations. This is 1, this is 2. I'm going to solve for y for each one. So I have 2x minus y equals -2. So I'm subtracting 2 x's on both sides. This equation, I get y, -1y equals -2 minus 2 x's. Divide all terms by -1. And y equals +2 plus 2x. So I rewrite this equation. Y equals +2 plus 2x. And this is y1. I'm going to erase this, so I hope you didn't write over your graph there. You should get another piece of paper to do this kind of work, right? So I have 4x minus 1y equals -6. Subtract 4 x's on both sides, or just use the margins of your paper. -1y equals -6 minus 4 x's. Divide both sides by -1. And y equals 6 plus 4x. So y2 equals 6 plus 4x. Okay, now we're ready to actually graph these equations. So for my first equation, equation number 1, m equals 2, or 2 over 1, b equals 2. So I go up to 2, go up 2, right 1, okay, and create my line. I'm going to draw a better line there. I don't like this one. Draw a better line. All right, that looks much, much better. So that's y. That's y1. y2, m equals 4, or 4 divided by 1. b equals 6. So up 6, right? And I want to go backwards, so I'm going to go down 4, left 1, down 4, down 4, left 1, down 4, left 1. And there's my point of intersection right there. This is a very steep line. And this is y2. Here's my intersection. That's at -2, comma, -2. And it's a one solution type of intersection. So I'm going to come down here and write -2, comma, -2, circle my intersection, right? And you're done. The next section is about using the TI-84 to find these solutions or these intersections. So we did this initially. So what we're going to do is go to y equals. You're going to go to y equals, put these equations in, and then press second graph. All right. So we go to y equals, put these equations in, press clear, clear, -2 for y1. For y2, we have x minus 3, right? Let me delete that out. And then we follow, if you're following directions, you're pressing second graph, and we're going to look for where the y values are the same. For where y values are the same, and we look, and it's at where x equals 1, my y values are the same, so that's the particular place for our solution. Our solution is, we're looking for x and a y, 1, comma, -2. That is our point of intersection. Graphically, what does this look like? Press trace, and if we look, we're at right here, that's 1, comma, -2. It's a point of intersection. Moving on, the classwork, you're going to be checking whether each ordered pair is a solution of the system of equations. So we're substituting these in, and we're just checking for y1 and y2. Does this ordered pair check out? So when I plug in, when I have, we're going to plug in -1. Well, we're going to check each equation. So you would have y equals -8x minus 8 on one side, and y equals 6x plus 6 on the other. So to check the first one, y equals 0. Does 0 equal -8 times -1 minus 8? 0 equals 8 minus 8, and this is true because 0 equals 0. So it checks out for this one, right? And then for the next one, does 0 equal 6 times -1 plus 6? Well, 0, does it equal -6 plus 6? 0 equals 0. So this checks out. But I got 2 check marks, so I can write my final answer. My answer here is that -1, comma 0 is a solution to the system. That's how you check your work. You should be doing this algebraically. That's 1, 2, and 3. Numbers 1 and 2, you're graphing the equations, identifying the solutions, and writing the number of solutions. All right. On the back, same thing. In the next class, you should be completing the homework for this lesson, and then you'll turn it in to me when we do lesson 2, substitution. Hope you guys have a great day. Thank you for watching.